Hello, my name is Sean Daniel Sylvester. I will now present the company background. This database project is focused on Soulbowl, a cafe that currently operates at two locations, University Malaysia Sabah UMS and UiTM Sabah branch. Established in 2020, Soulbowl specializes in offering desserts, beverages, and mainly Western-inspired menu items to cater to the tastes of university students. Soulbowl's vision is to be the go-to cafe for students, offering quality meals that combine value, affordability, and a welcoming atmosphere, fostering a sense of community within university campuses. Its objectives are to achieve sustainable profitability, to create job opportunities for the community such as students and local residents, to ensure customer satisfaction by consistently delivering excellent service and quality meals. Its mission is to provide students with diverse quality food options, to offer affordable meals to fit student budgets, and to continually refine and expand menu offerings to meet students' preferences. Here is the organizational chart with the chairperson slash main shareholder at the top of the chart, the manager who handles marketing working right below them, and then working below the manager is the accountant, and below that all the customer service staff. Here are all our entities, all 14 of them, which are customer, category, staff, supplier, order details, orders, location, menu item, invoice details, invoice, receipt, daily profit, monthly profit, and inventory. I will now present the current system description. Firstly is inventory management. The staff manually track incoming stock and maintain records on paper or spreadsheets. Products delivered by suppliers are recorded in a physical invoice file, and stock levels are updated manually. Stock availability is checked by staff before preparing customer orders. Secondly, customer order processing. Orders are recorded manually by staff. Sales data, including customer details, and purchased products are entered into a spreadsheet at the end of every day. Next is supplier management. Suppliers deliver products based on manual orders placed by the cafe. Invoices from suppliers are stored physically and payments are tracked separately in a ledger. Staff management. Staff schedules and records are maintained manually in separate files. There is no integration between staff performance and sales data, creating additional administrative work. Then there's monthly profit calculation, where sales and expense data are compiled manually at the end of the month to calculate profit. Errors are common due to inconsistent or incomplete records. Next, receipt generation. A receipt is generated for each customer order, documenting the customer name, date of the transaction, and total price. Each receipt must reference the customer who've made the order. Lastly, daily profit calculation. Each day has one record in the database that tracks the total revenue, total cost, and net profit for that day. Daily profit is calculated based on the total revenue from customer orders minus the total costs incurred.
I'm Rina, and I'll be presenting our entity relationship diagram. It shows how different parts of our system connect and work together. Now let's go over the entities and relationship. Customer represents people who buy from the cafe. A customer can place many orders, and each order contains several products. Staff manages orders, suppliers, and stock levels. Staff handle customer orders, place supplier orders, track deliveries, and update inventory. Each order is processed by one staff member. Supplier provides products for the cafe. A supplier sends many invoices for the products they deliver. Invoice records product deliveries from suppliers. Each invoice includes many products, and payments are tracked separately. Invoice details show what's in each invoice. One invoice has many invoice details, but each invoice detail belongs to one invoice. Menu item represents the food and drink sold at the cafe. Menu items are linked to stock levels and included in customer orders. Receipt records customer purchases. Each receipt is for one customer order. Order represents customer purchases. Each order has one customer, one staff member, and many products. Order details shows what's inside an order. One order has many order details, but each order detail belongs to one order. Category groups menu items such as desserts, beverages, and Western dishes. Each category contains many menu items. Inventory tracks available stock. Each menu item appears in inventory records. Staff updates stock and order from suppliers when needed. Location represents cafe branches, which are UITM Sabah branch and UMS. Staff works at a specific location, and each location has its own inventory. Daily profit tracks daily sales and expenses. Each day has one profit record. Monthly profit summarizes profit for the whole month.
Hello, my name is Faye Aurelie Alvin, and I will be presenting the normalization stages for our project. There are 3 stages of normalization, and for the first one is the first normal form. In the first formal form, we identify the primary key, and there are also partial and transitive dependency. The first normal form is important as to ensure each column contains atomic or indivisible values and remove duplicate columns. For the next stage is the second normal form. In this normal form, we create new tables in order to eliminate the partial dependencies. In the second normal form, we have in equal of 12 tables. Now, we refine our database further by eliminating transitive dependencies where a non-key attribute depends on another non-key attributes rather than the primary key. There are 3 main fixes in the third normal form, which is we remove transitive dependencies by creating separate tables. It is to ensure every non-key attribute depends directly on the primary key. So, in the third normal form, we have in equal of 14 tables. By applying first normal form, second normal form, and third normal form, we have created a structured, efficient, and scalable database. This ensures accurate data retrieval and avoid anomalies.
Next, this is our data dictionary, where it defines the structure of our database, which includes table name, attribute name, data type, nullable, primary key or foreign key, and reference table.
For data definition language, first we create a table for customer which has customer ID as their primary key and customer name for other attribute. Next, we create a table for menu item which has product ID as the primary key, product name, price and category ID as the attribute. We derive the category ID from the category table as a foreign key. Next, we create a table for category which has category ID as the primary key and category name for the attribute. Next, we create a table for location and we use location ID as the primary key, location name, location address, and location number telephone as the attribute. For staff table, we use staff ID as the primary key, staff name, staff position, and staff number telephone as the attribute, and we derive location ID from location table as a foreign key. For the supplier table, we use supplier ID as the primary key, supplier name, supplier number telephone, and supplier address as the attribute, and we derive staff ID from table staff as a foreign key. Next, we create a table for orders which has order ID as the primary key, order date, and total price as the attribute, and we derive staff ID and customer ID from the table staff and customer as a foreign keys. Next, for table invoice, we use invoice ID as the primary key, invoice date, total cost as the attribute, and we derive supplier ID from table supplier as a foreign key. For order details table, we have quantity and subtotal price as the attribute, and we derive order ID, product ID, and price from table order and menu item as the foreign key. Next, we create a table for invoice detail which has quantity, cost, and subtotal cost as the attribute, and we derive invoice ID and product ID from table invoice and menu item as the foreign key. For inventory table, we have inventory ID as the primary key and stock quantity as the attribute, and we derive product ID and location ID from table menu item and location as the foreign key. In addition, we create a table for daily profit, which has daily ID as the primary key, daily revenue, daily cost, daily profit as the attribute, and we derive month ID and order date from table orders and monthly profit as a foreign key. For table receipt, we use receipt ID as the primary key, and we derive customer ID, order date, and total price from the table customer and order as a foreign key. And lastly, for table monthly profit, we use month ID as a primary key, month name, total revenue, total cost, fixed expenses, and monthly profit as the attribute. For 5 SQL questions, question number 1, display the customer ID, order date, and total price that exceeds 15 ringgit. Sort the result in ascending order of the total price. First, select the customer ID, order date, and total price from orders entities, where the total price is more than 15 ringgit, and order it by total price ascendingly. For question number 2, display the order ID, product ID, and quantity for all orders where the quantity of the product is less than or equal to 3. Sort the result by order ID, then by quantity. First, select order ID, product ID, order quantity from order details entity, where the order ID is less than or equal to 3, and order the order ID and order quantity ascendingly.
For the third question, we are out to display the product ID, name, and price, then display the result in a descending order of the product name. The solution is that we select product ID, name, price from menu item and order by product name in ascending order. And for the output, it will display the result in ascending order of the product name. For the next question, which is question 4, we are required to display the product name, product ID, and price for all product where the price is between 7 ringgit and 10 ringgit. Sort the result in descending order of the price. The solution is we select product name, product ID, and price from menu item where the price is between 7 and 10, and then we order the price by descending. The output will be, it will display the product name, ID, and price for all product where it is 7 ringgit and 10 ringgit in between, and in descending order of the price. For the fifth question, we are required to display the total profit for each day from the daily profit table, where only include days where the total profit is greater than the average profit calculated across all days. For the solution, we select order date, sum daily profit as total profit from daily profit and group by the order date, having that the total profit is larger than the average daily total from sum of the daily profit as the daily total from daily profit and group by order date. All of this as the daily totals. So the output will be that it will display the total profit for each day that only includes where the total profit is greater than average profit calculated across all days. For the last question, we are required to display the customer's name and the assigned staff member name for the customer with the customer ID of 98. For the solution, we select customer name and staff name from orders, and then we join both of them. This is a sub-query, so we can access the staff ID without having it as the foreign key for the orders, where the customer ID is 98. So the output is the staff name, which manage the customer name with the customer ID of 98. These are the references for our project, and that's all from us. Thank you.